Hello Europe, hello Lithuania, hello Šiauliai and Dr. Lamanauskas, hello all colleagues, the educational researchers. I'm going to present today about chemical eponyms in the epoch of educational ethnocentrism. Eponymy is a word of Greek origin made up of epi, over and noma, name. It means giving name to something or naming after something or somebody. Eponyms are word combinations, often scientific terms, denominating a phenomenon, a law, a theory, a principle, an invention or a procedure with the originator's name. Term eponym is more scientific, but there is another term more understandable, named something. For example, named reactions, named laws, named effects. Even though this term is widely used for particular items, the generic two-word combination named notion is rare and misleading. Eponyms are abundant in science and technology, in medicine, in geography, as you see them being scrolled here. Moreover, they are smartly played around in marketing. Here's what I saw in our local store when browsing fruit on shelves. I ran into an Italian chemist Amedeo Avogadro's portrait on a pack of avocados. Avocados number. By this time, eponyms have been well inventoried. There are books on chemical eponyms, medical, physical, geographical, engineering. Perhaps the most ultimate is this book of 1977, Eponyms Dictionaries Index. It comprises about 20,000 eponyms. However, as we will see, even this edition is not exhaustive. Eponyms are researched from sociological, linguistic, and what is important for us, from pedagogical perspective. Addressing eponyms in science education, Govindarajan and Rao mention anecdotal and historical merits of eponyms and argue learning of eponyms in science education can significantly enlighten the motivated as well as the disinterested student to embark upon diligent and productive endeavor in education and to relate the knowledge to present-day life and society. Eponyms possess two pedagogical potentials, didactic and axiological. The former is obvious. Students should study eponyms just because they are a part of the subject. Being a form of shorthand, they make professional communication easier because specialists quickly recall their content and understand the subject. What is amazing, and we showed it in a recent publication, eponyms, and not only chemical eponyms, can be characterized using the same theories as molecules are characterized, valent bond and molecular orbital theories. Eponyms form when relevant information about the discovery and its author overlap nicely, thus creating a bonding orbital. Stability of the two-word system increases, internal energy lowers. So one can prove eponym formation with thermodynamics. The latter potential, axiological, lies in introduction of values. With teachers' initiative, every eponym can be unwrapped either into a fragment of the scientist's biography in the context of his discovery or into details of his discovery, flavored, humanized with the scientist's personality. Through eponyms, teacher can convey important values to students. The axiological approach puts up a principle of humanization in education, which implies that along with subject knowledge, educational task should include additional information on human activity in various aspects, such as history and art. This principle of humanization in education, as well as another good principle of historicism, is either manifested as such or present implicitly in many national documents governing education, including, say, US National Science Education Standards of 1996 and the US Next Generation Science Standards of 2013, Belarus Concept and Standard of Chemistry as a Subject, year 2009. This is why we address this topic, since eponyms, with respect to their didactic and axiological potentials, are a part of history of science, and teaching eponyms is in line with humanization and historicism. Reviewing literature for a dictionary of chemical eponyms, 106 sources in Belarusian, English, Latvian and Russian languages, 1,642 eponyms were identified, including named assets, adapters, apparatus, bases, catalysts, condensers, and so forth. Among the reviewed sources, one published in 1959, focusing on teaching chemistry, looked unusual. It mentioned 6 eponyms named by the author of the book. The author is an outstanding authority for teachers in the post-USSR countries. He really himself invented, developed, advanced and checked a number of experiments and devices. Some of them saved his name in theirs. So, not to question Verkhovsky's authority, but to check current usage and longevity of his eponyms was our research goal. To achieve this goal, we analyzed the book in question and searched on the internet for Verkhovsky eponyms, verbatim, in Russian and English, using such services as Google Scholar, Google Books, databases EBSCO, Academic Search Premier, Web of Science, eLibrary.ru, and others. The book mentions 6 eponyms and contains images of 5 of them. Verkhovsky's burette, Verkhovsky burner, Verkhovsky clamp, Verkhovsky audiometer, Verkhovsky stand, Verkhovsky ozonator. Ozonator is mentioned on the page next to audiometer but not described. What are the results? The internet search revealed the following eponym occurrences.
Verkhovsky burette, 0 occurrences verbatim, 52 other occurrences, including publications by Teleshov, Kutumov and Stopin on laboratory techniques, listings of burette along with other glassware. Same text in the following context. Sure enough, there are not all chemical devices. In our article, we did not mention Devi lamp, Renault picnometer, Verkhovsky burette. On query Verkhovsky burner, the search engine returned the same publication by Stopin 2 times. The phrase Verkhovsky burner consists of 2 tubes. Verkhovsky clamp finds itself on the internet only once, in the book by Goryachkin, a physics methodologist, Verkhovsky's contemporary. Verkhovsky audiometer occurs on the internet 6 times, including publications by Fadeev, Zlotnikov and Teleshov. Characteristic quotation here. Till nowadays one can hear in school practice, Verkhovsky audiometer. Verkhovsky stand occurs on the internet 29 times, including the earlier quoted quotation by Fadeev, Zlotnikov and Teleshov. On query Verkhovsky ozonator, its description is missing in the first volume of the book but is present in the second. We have 6 mentions, including publications by Fadeev, Zlotnikov and Teleshov. The same characteristic phrase, till nowadays one can hear in school practice, Verkhovsky ozonator. Besides those mentioned in the book, there are also Verkhovsky test tube 6 times, Verkhovsky Sazonov test tube 4 times. Here we see publications by Fadeev and Teleshov, but also listings from internet shop where one can buy the test tube. Verkhovsky apparatus 6 times. 5 of the 6 sources contain the same text. If the funnel in KEEP apparatus is broken or missing, one can utilize Verkhovsky apparatus. One source that is dissimilar describes a different Verkhovsky apparatus. There are 2 of them, one for gas generation, another for liquid distillation.
So all these findings relate to the queries entered into Google in Russian. As for those typed in English, even in multiple versions with respect to variability of using possessive case and transcription from Cyrillic script, Verkhovsky, 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 Verkhovskis, 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 Verkhovskis. No traces of the eponyms were found. Moreover, there appears only one page where the scientist himself is described in English. That's Russian Information Network. So, our search revealed that Verkhovsky eponyms do not occur in modern internet publications as applied to current laboratory practice or teaching chemistry. They are sometimes mentioned in a Russian segment of the internet as a historic legacy of the great Soviet chemist. Why aren't Verkhovsky eponyms mentioned in English internet? Well, one should understand that eponyms do have their fate. They arise, live their active life, may undergo transformations, often unpredictable, may drift from one country and domain of usage to another, may be even banned, may become less and less used, and finally forgotten. Scientific eponyms popular in one country are not necessarily welcome in another country. To illustrate, let us consult this dictionary. The person who has been eponymized the most was French chemist Georges Denisger with 80, just imagine, 80 phrases, including Denisger's microtest for novocaine and Denisger test for uric acid. And there are Denisger's eponyms in Russian chemistry too, for example, Denisger reactions, but not 80. Carl Friedrich Gauss, a German mathematician, is listed in this dictionary with 56 eponyms. Can a math teacher in Russia or Lithuania or Poland name them all? By the way, Jesus Christ here has 45 eponyms, only, same as Isaac Newton. Meanwhile, such Russian chemists as Zinin reaction, Butlerov synthesis are missing in this edition. It references only English sources. So no wonder that Verkhovsky eponyms are or were in wide use in Soviet Russian chemistry but unknown in modern English chemistry. Finally, as it were Russian Soviet inventions, it is not surprising to see an extensive usage of Verkhovsky eponyms in Russian language chemistry compared to other languages. The second question is how come that Verkhovsky's book contains so many Verkhovsky eponyms? Who was the initiator of Verkhovsky eponyms? He himself or somebody else? Well, Verkhovsky is the author of the book in question, so whether he branded his inventions his name or was advised or pushed to do so, he was aware about this self-eponymization. There are examples in history. Physician Jack Lips invented an intrauterine contraceptive device and called it so, Lips Loop. Engineer Seymour Cray designed the Cray supercomputer. Frankly, when I was a graduate student in 1989, I myself used existing Soviet patent law, which allowed the inventor to officially register his invention, carrying his name. And I received a certificate on invention, Slabin's type. Today, patent law in Russia does not recommend using names in the invention title, though it does not forbid either. And so does US patent law, asking for a specific and descriptive invention title, not a personal name. The real honor, however, lies in having someone else bestow the tribute upon the author, having a messenger. The reason why so many eponyms could originate from one author and be self-introduced in his book can be assigned to ethnocentrism. In the beginning, education in Europe used to be universalist in character. Universal phenomena were explained in terms of a single coherent value system. generally from the point of view of religion or ideology. But then the interest in specific national characteristics arose during the Enlightenment and developed alongside the establishment of bourgeois societies in the 19th century, in parallel with the emergence of a universalist view of education. By the latter half of the 19th century, political power and public opinion had paved the way for education to become more national in character, for national identity to become stronger, and for the newly created traditions to be handed down in such a way as to appear almost everlasting. It seems that values such as national tradition and national characteristics pervaded all education, and as general principle in the mid-19th century. In countries where the creation of a new type of national identity became the order of the day, Germany and Italy, and as well in countries which sought their own national identity within a multinational state. After the Second World War, it seemed for some time that ethnocentrism would give place to several types of universalism in quick succession. First, mankind, then the free community of nations liberated from fascism became the ideal. Establishment of the United Nations and its specialized agencies. However, later in Eastern Europe, the idea of a socialist national community with a system of values assumed to be universally socialist in nature gained hegemony. And in the late 20th century, ethnocentrism gained strength. National identity and national differences became important once more in Eastern Europe, as well as in many other parts of the world. Ethnocentrism projected into history and literature, humanities first of all, but science education too. If ethnocentrism is still notable in Europe, one can imagine how especially strong it was in the Soviet Union, the country in the epoch where and when Verkhovsky lived and his book were published. In 1946, academician Kapitsa sent Stalin a letter in which he stressed that a great number of discoveries was anticipated in Russia. Now it's time to renovate the industry and to train specialists, he said. To do so successfully, one should believe in our own creative potential, Kapitsa said. Well, saying so, he was not the pioneer. Mendeleev, the inventor of the periodic system of elements, believed that the task is not to train engineers and scientists, but the task is that engineers and scientists, upon receiving their diplomas, remain Russian in all senses. If we imagine the atmosphere in the society at that time, Verkhovsky's book was published in 1959. No wonder that it contained 6 eponyms of his own as a manifestation of Russian creative potential embodied into specific scientific items. And probably it's not bad for the historians of science. Scientific knowledge is impersonal in the sense that its claim to truth must be assessed apart from its source. But at the same time, one should prevent this knowledge from sinking into anonymity, to preserve the collective memory of its origins. Eponymity, not anonymity, is the standard. The third question is, how come that Verkhovsky eponyms vanished from Russian chemical usage? It can be, of course, that laboratory equipment since his time became more advanced, sophisticated, and replaced his inventions. There is also a described trend that eponyms, especially in analytical chemistry, became rare in the post-1960 period. There can also be another reason. As a rule, names to scientific achievements are not given by historians of science or even by individual scientists, but the community of practitioners. Also, names are rarely given nor generally accepted unless the messenger is remote in time and place, or both, from the scientist being honored. For this statement to be true, an eponym must not only be awarded on the basis of scientific merit or originality, but it must be perceived by practitioners as based on merit and not personal friendship, national affiliation, or the political pressure. Where these requirements met at the time of Verkhovsky eponyms, we don't know. Insufficient historical data and available are sources to answer, but if they were not, it can be an explanation. Finally, the last but not the least question on this history is what are recommendations for chemistry teachers introducing eponyms at their lessons with principles of humanization and historicism in mind? Well, forgotten eponyms per se do not create an issue, so not to mention them is one way. There are a lot of other national eponyms to teach and educate. Alternatively, one can teach Verkhovsky eponyms despite them being forgotten, to revitalize interest to the national scientific history. But whether a teacher decides to teach Verkhovsky eponyms or to refrain from it, their history is a good example of science as a human endeavor, a cross-cutting concept present in many educational standards of the world. Thank you for your attention.